Welcome to your year-long journey through the cosmos. In this beginner-friendly astronomy series, we'll delve into our solar system and its planets, formation of stars and galaxies, uncover the mysteries of black holes, explore the universe's structure and origins, and search for life beyond Earth. As you continue watching the videos in this series, you'll gain the confidence to understand the foundations of astronomy and navigate the wonders of space. If you're ready to begin this cosmic adventure, let's take our first step into the stars. Before starting this journey, I will first briefly touch upon what science is and what methods it uses. Science is the accumulation of knowledge that humanity has acquired over thousands of years and the method by which this knowledge was obtained. However, science also gives us the honesty to accept that we may be wrong. Science reveals that everything we currently know, and even some of it, may be wrong. We observe nature and the universe, make predictions based on our observations, and conduct research and experiments to either support or refute these predictions. This part, which we call the scientific method, is very important. A scientist must first and foremost be honest and objective, evaluating results through reason rather than emotion, because the only way to reach the truth is to make mistakes and accept that we can be wrong. Science is a process of trial and error. In this process, scientists may sometimes stray from the path, but in the long run, they get a little closer to the truth each time. This is the greatest strength of science. Now, let's evaluate this scientific method in the context of astronomy. Astronomy is, in the truest sense of the word, a science that seeks to understand our place in the universe. Thanks to astronomy, we know that our planet is a sphere made of rock and covered by water, that the sun is a star millions of kilometers away that warms and illuminates us, that the sun is an ordinary star in the Milky Way galaxy orbiting the center of the galaxy, and that our Milky Way galaxy is just one of hundreds of billions of galaxies in the universe. All this information has been learned and obtained through thousands of years of human observation and experimentation. This scientific method in astronomy has enabled us to realize the size of our planet and its place in the universe. Astronomy not only teaches us about our place in the universe, but also about who we are and how the dynamics of our universe work. When we talk about astronomy, many people think of looking at space through a telescope and making observations. An astronomer, someone who works in this field of science, is thought of as someone who looks at the stars and planets in the sky or discovers a comet. However, modern astronomy has gone far beyond this stereotype. Of course, astronomy is concerned with studying objects and events in the sky, but this definition has become much more complex and multidisciplinary today. Therefore, the definition of astronomy is not limited to just studying space, but rather encompasses or intersects with many other scientific disciplines. The best example of this is the surface research rovers sent to Mars. These robots have obtained a great deal of geological data by photographing the surface of Mars and conducting excavations. At the same time, they have analyzed the chemical structure of Martian soil through excavations, providing us with insights into Earth's past. Observing Mars through telescopes is indeed astronomy, but it is also chemistry, geology, and robotics engineering. Another great example is the discovery of an exoplanet orbiting a star hundreds of light years away from us. Not only is its existence detected, but its atmosphere is also analyzed to determine which elements are present on the planet. To do this, a method called spectroscopy, which is used in physics to understand the structure of light, is employed. By analyzing the structure of light, clues are obtained about which elements may be present on the planet and even whether life exists there. A modern astronomer does not just use a telescope to determine the location of stars. They also observe how the star was formed, the elements in its structure, and whether there is life on the exoplanets orbiting it. Astronomers work with engineers, data scientists, programmers, and physicists to understand how the universe works, so that the telescopes used can be larger and more powerful. For this reason, astronomy today is an interdisciplinary field that involves collaborative work with other sciences and engineering disciplines. Astronomy not only allows us to observe the complex structure of the universe, but also helps us understand it as a whole. Additionally, you don't need to board a spaceship or have an academic degree to become an astronomer. Anyone who is interested in the universe loves to look at the stars and wants to understand what is happening in the boundless sky above our heads can be an astronomer. If you carry this curiosity and interest within you, then you are already an astronomer. We have prepared this series to bring out the astronomer within you. So how did we acquire our knowledge about space? The answer lies in thousands of years of human observation and scientific revolutions. Although the origins of astronomy are often associated with the invention of the telescope, its history actually dates back much further to the ancient times when Homo sapiens, the intelligent humans we know today, our ancestors observed the night sky every night, free from the light pollution of the modern world, and noticed the moon and the changing patterns of the stars with the seasons. During the day, they observed the sun and understood how it followed a periodic path across the sky throughout the year. All these celestial movements were of great importance in determining the time for farming as humans began to settle down. Our ancestors prepared calendars by observing the periodic movements of celestial bodies, and in this way they determined when to sow and when to harvest. However, as humanity continued to observe, they began to realize that they could not control these cycles and started to seek a spiritual reason behind such regular periodic movements. Thus, they began to use the sky not only as a calendar, but also as a belief system. They even combined their beliefs with their agricultural activities, performing religious rituals and ceremonies, and making prophecies. This stage led to the emergence of astrology. At first, astronomy and astrology were intertwined, and there was no distinction between them. However, over time, humanity developed philosophical thought and began to make logical deductions from their observations, which led to a journey of scientific discovery and the birth of astronomy. Astrology, on the other hand, became increasingly esoteric, moving beyond reason, logic, and observation to become a mystical belief system. Unlike other ancient civilizations, the ancient Greek civilization saw the emergence of philosophy as a result of the beginning of free thought movements. Thanks to philosophy, ancient Greek thinkers laid the foundations of scientific thought for the first time and began to separate astronomy from belief systems, turning it into a pure science. In doing so, they questioned how the movements of celestial bodies could occur, rather than the existence of a spiritual power behind them, and put forward the first models of the universe. They developed many models by observing in detail the shape of the Earth, how the planets move differently from the stars in the sky, the position of the Earth in the universe, and the movements of the moon and sun throughout the year. Although some ancient Greek astronomers proposed a sun-centered model of the universe, this model was not accepted at the time due to a lack of observational data, and the Greek philosopher Ptolemy of ancient Rome developed an Earth-centered model of the universe. Ptolemy's model was so well developed based on precise observations that it functioned almost perfectly. In fact, this model of the universe was widely accepted and even regarded as a sacred truth in major religions such as Christianity and Islam, regarding the creation of the universe and the position of the Earth in the universe. However, the scientific revolutions that took place in the 16th century under the influence of the Renaissance led to the collapse of the geocentric model of the universe, which had become a matter of faith for almost 1500 years. First, Copernicus proposed the heliocentric model of the universe, which was later strengthened by Tycho Brahe's observations and Kepler's magnificent mathematical formulas explaining these observations. The Italian astronomer Galileo Galilei dealt the decisive blow to the geocentric model of the universe. He further developed and redesigned the telescope invented by the Dutch for use in navigation. Unlike everyone else, Galileo used it to study the sky rather than the seas. As a result of his shocking observations, Galileo discovered Jupiter's moons, which contradicted the geocentric model of the universe described in the sacred texts up to that point. The sacred texts claimed that the Earth was stationary, did not rotate, and that all celestial bodies revolved around it. However, the moons revolving around Jupiter dealt a major blow to this belief. Another striking observation by Galileo was his observation of the phases of Venus. By tracking the direction and brightness of these phases, Galileo realized that Venus did not revolve around the Earth but around the Sun. As a result of his observations of other planets, Galileo was now certain that the sun-centered model of the universe was correct. Although some astronomers objected to the ideas that emerged as a result of these observations, Galileo had placed a powder keg at the foundation of a 1,500-year-old belief. However, the ideas he put forward as a result of these observations were vehemently rejected by the Catholic Church, and Galileo was tried by the Inquisition. Threatened with death if he did not renounce his ideas, Galileo backed down. However, he was ultimately sentenced to house arrest for life. During his house arrest, Galileo compiled all his work into a book and arranged for it to be secretly smuggled out of Europe and reproduced in other countries. The recent invention of the printing press at that time led to a new scientific revolution throughout Europe. These discoveries not only sparked a scientific revolution, but also initiated a religious, cultural, and intellectual transformation. In the year of Galileo's death, another person who would spark a scientific revolution was born in another part of Europe. This person was Isaac Newton, whom many of us are familiar with. Newton claimed that Aristotle's conclusions about physics, which had been accepted by everyone for 2,000 years, were wrong and began to rewrite physics. Of course, Isaac Newton's work was not limited to physics. He also developed revolutionary methods in mathematics to explain physical concepts in mathematical terms. Calculus, which is considered an indispensable part of mathematics taught in high schools and universities today, was developed independently by Isaac Newton and his contemporary, the German Wilhelm Leibniz. Thanks to calculus, Newton succeeded in translating many physical theories into mathematical language and developed the theory of gravity. What made Newton so exceptional was his ability to explain the laws of nature using mathematical expressions, a universal language. Of course, there is no such thing as absolute truth in science, which constantly progresses by eliminating errors or filling in gaps in order to approach the truth. Indeed, the flaws and errors in Newton's theories on gravity were discovered by Albert Einstein approximately 200 years later. Einstein discovered the magical world of light and explained why the speed of light is the highest speed in the universe with his revolutionary special theory of relativity. Einstein explained that time is not absolute and can vary depending on the observer. According to this theory, time flows differently at different speeds. As one approaches the speed of light, time slows down for an outside observer. Einstein later combined this theory with his theory of gravity and discovered that time also progressed differently at different masses. This theory, called the general theory of relativity, overturned Newton's theories of gravity and led to their rewriting. We will examine these concepts in detail in other episodes of our video series. The further development of the telescope in the 20th century paved the way for even greater discoveries in space science. Our view of the universe had now expanded to distances we could not even imagine. Not only the invention of the telescope, but also the invention of the camera and the development of photography made it possible to record our observations. Thanks to the increased diameter of the developed telescopes and the long exposure capabilities of cameras, we were able to photograph faint celestial objects in the depths of the universe that were invisible to the naked eye. This expanded our discovery capacity to incredible dimensions. The development of radio telescopes and the invention of digital sensors enabled us to build more advanced telescopes. Indeed, these telescopes were not only based on Earth, but were also taken beyond it. Space telescopes such as Hubble and James Webb discovered and photographed previously unseen parts of the universe. In the 20th century, developments in astronomy were not limited to the observational realm. Advances in rocket technology paved the way for humankind to venture into the depths of space. We set foot on the moon, sent numerous unmanned spacecraft and robots to the planets of the solar system, and even managed to venture beyond the solar system. Of course, all these developments did not happen overnight. They were made possible by the cumulative knowledge of humanity over thousands of years. It had only been 400 years since Galileo's discoveries until we set foot on the moon. The fact that we were able to reach this point in such a short time is the greatest evidence of the rapid advancement of scientific knowledge. Today, new discoveries are made almost every day. This long journey has brought us to where we are today in our understanding of the universe. But remember, science is constantly evolving, and we can only directly observe 4% of the universe. There is still so much left to discover. And with that, we've reached the end of our first chapter. We've only just scratched the surface of what astronomy is, how it collaborates with other disciplines, what is the role of an astronomer, and the incredible historical journey we've taken to understand our place in the cosmos. The universe is full of secrets waiting to be solved. If you enjoyed this first episode of Astronomy for Beginners, make sure to hit that subscribe button and ring the bell so you don't miss our future chapters, where we'll dive deeper into the world of planets, moons, stars, galaxies, and beyond. Leave a comment below with what you're most excited to learn about, and I'll see you in the next one.